Hello, I'm Dr. Shlomit Becker, and I'm a postdoc fellow at Albert Einstein College of Medicine in New York. I'm going to tell you about my study on predictive anticipation and rhythmic tracking in children with autism, done at the lab of Dr. Sophie Mulholm together with Dr. John Fox. As you will see in my presentation, kids on the spectrum show significant impairments in anticipation and rhythmic tracking processes. Information in the environment is known to be very predictive of upcoming events. However, this is not the case for people on the spectrum, who show deficits in using cues to generate expectations. Still, the underlying neural mechanisms are unknown. In our experiment, 31 children with autism and 20 typically developed participated. All were between 6 to 9 years old. The diagnosis of ASD was done through ADI and ADOS by a trained psychologist. The experiment included two conditions. In the no-cue condition, there were trials that included 4 consecutive visual cues that were presented with SOA of 650 milliseconds. This sequence was followed by an auditory target. In the no-cue condition, no visual cues were presented, just the auditory target, to which participants responded. We used 64 channels EEG to record scalp activity. We also recorded behavior and pupillometry to monitor gaze. First, to behavioral results. Overall, ASD participants showed slower responses than controls. Both groups showed faster responses to cue condition than to no cue condition. No interaction between cue and group was found. For the EEG results, ASD and TD showed similar visual evoked potentials across all visual cues. However, a significant difference between the groups is seen at a late time window between 400 to 700 milliseconds. To unpackage this difference, we looked at each signal prior to a cue separately. We can see that for the TDs, the signal voltage became more negative as a function of cue order at frontal locations. This pattern is known as contingent negative variation, and it is observed when expecting a target. This typical pattern is not seen, however, for the ASD participants. Next, we wanted to know how the brain signals align with the sequence of stimuli. When plotting low-pass filter of this signal, we can see that on average, ASD participants are less aligned with the cue onsets. This is also found in the phase concentration analysis. The phases were significantly more spread for the autism group. The inter-trial phase coherence analysis shows how well phases of different trials are synchronized. We can see two effects in this group difference plot. First, the ASD group has lower synchrony of phases, and second, this lower synchrony becomes more significant and stronger prior to cue onsets. This convinced us that brain signals of ASD children show reduced anticipation for the stimuli. Finally, we wanted to know if ITPC is correlated with a behavioral measurement. We found that it is. There is a negative correlation between variability of reaction times and ITPC. The more participant brain is aligned with the stimuli, the more coherent his responses are. K-means classification shows that most TD participants are concentrated in the high ITPC, low reaction time variability end of the graph, whereas ASD participants are mostly concentrated in the lower ITPC and high reaction time variability end of the graph. To summarize, EEG results indicated significantly reduced predictive processing and impaired tracking of periodic stimuli in children with ASD compared to controls. Synchronization of neural oscillations, necessary for cognitive processes that are built upon precise timing of neural responses, such as tracking and predictive processing, may be compromised in autism spectrum disorder. That's it. I hope you enjoyed it. For more questions, I'm happy to answer in my email. Thank you very much, and bye-bye.